Now in this video we're going to take a particular function, but this time rather than using our derivative to find the gradient, we're going to look at when we're given the gradient and we have to find where that gradient is happening. So it's, again, I'm going to use it for this graph here, and you can see at this point here the gradient is 1. Now on the left hand side of the screen in red it says m equals 1, and that's calculated by 1 divided by 1. So I know at this point here at 2, 2 we get a gradient of 1, and that's what I'm going to prove to you now. So it might say something along these lines. So for this function, or for a function, blah blah blah, calculate the value of x, or it could even say find the location, or what is the coordinate that gives a gradient of 1. Okay, so with all calculus, the first thing you're going to do is dy by dx, find the derivative. So if you're ever in doubt, just if you don't understand the wording, just do that and you've got some marks. Okay, so normally this, we plug in an x value that will give us the gradient, but this time we've got the gradient. So that means, therefore, dy by dx must be equal to 1 from this statement here. Our gradient function, our derivative, must equal 1. And therefore, 2x minus 3 must equal 1. And now I solve it like a linear equation. So 2x is equal to 4, and x is equal to 2. And that's done. So here we have calculate the value of x. So that's the value of x. You've got to be really careful with the question. If it asks for the coordinates, you then have to find out what y would be. So here, from y, we know to find any value of y, we take the value of x, square it, take away 3 lots of the x, plus 4. So it's going to be 2 squared minus 3 lots of 2. I only put it in brackets to show that I'm substituting it in. Just think it looks so much nicer. So it's going to be 4 minus 6, add 4. Okay, so minus 2, add 2 is 2. So therefore the coordinate, it actually happens at 2, 2. If we look at the graph, there you go, 2, 2, gradient of 1. So just so you fully get it, let's say the gradient is now 5. Okay, so we have our derivative. Now, why not pause the video, follow what I did, have a go at finding the location of where the gradient is 5. Okay, so hopefully you've done that now. So what we can say is dy by dx is equal to 5. And please never skip this line of working. It's just showing your examiner that you fully understand what you're doing. So we can put these two statements, these two functions, together. So 2x is equal to 8 and x is equal to 4. That's the x location. But if you want to find the y, you're going to have to plug it into this function up here. Oh, I nearly crossed it out. So 5 squared minus 3 lots of 5, add 4. 25, take away 15, that gives us 10. Add the 4. Oh. What am I doing? Sorry, these are meant to be 4s. That's embarrassing. I'll just redo this line here. So it's 16 minus 12, that gives us 4, plus 4, and that's 8. I got distracted obviously with this, but I was plugging in 4 because that was our x value. Now in the next video we're going to have a look at what happens when the gradient is 0, and they're called turning points. Okay, so make sure you tune in for that one.